second part. Okay. So question number 7, second part. The complete board is visible. Yes.
Yes, sir.
Okay. So here, what is given? I is equals to integral x e raised to power 2x divided by 1 plus 2x whole raised to power 2 dx. Okay. So, which property we were applying in the last class? Same property can be applied here also. So, we were applying integration of e raised to power x, f of x plus f dash of x, and this integral is equals to e raised to power x f of x. Okay. So, this was the last property which we are applying. So, how we can apply this here? So, first we have to replace this 2x. We have to substitute this 2x in terms of a single variable. आई थिंक हमने ये क्वेश्चन किया था क्या? लास्ट क्लास में नहीं किया था, देख लेते हैं चलो.
No, sir.
Okay, so first thing what we can do, we can substitute 1 plus 2x is equal to t. That can also be done, or simply 2x is equal to t. We can do that also. So let's try. First, I'm substituting here 1 plus 2x is equals to t. Let us consider 1 plus 2x is equal to t. Okay. So, so the value of x will be t minus 1 upon 2. Yes. So the value of x will be t minus 1 upon 2. Now, if you differentiate this, you will get 2 is equal to dt by dx. And further, after solving this, you will get dx is equal to dt by 2. Okay, correct? Now, this complete integral will become I is equals to integration in place of x, write this t minus 1 upon 2 e raised to power t divided by, in place of this term, that is 1 plus 2x, write t, so it will be t square, and in place of dx, write dt by 2. Is this step
Excuse me,
clear?
sir.
हाँ बोलो.
E raised to power t, how?
देखो, अच्छा नहीं, हाँ मैंने गलत किया ना. e raised to power 2x जो होगा वो t minus 1 होगा ना. सॉरी, करेक्शन. यस, ठीक है. अभी
Yes, sir.
नेक्स्ट स्टेप, I is equals to इंटीग्रल. अब देखो यहाँ पर ये 1/2 इट विल बी 1/4. ओके, दिस टर्म विल बी t minus 1 upon t square into, here we can write e raised to power t upon e dt. Is this step clear? 1/2 को 1/4 लिख दिया. t minus 1 upon t square वाली टर्म, e raised to power t minus 1 को e raised to power t upon e raised to power 1 इस तरह से लिख दिया. क्लियर?
Yes, sir.
अब देखो यहाँ पर ये 1/4 वाली टर्म और ये e वाली टर्म, ये दोनों टर्म्स कांस्टेंट है, तो हम इसको इंटीग्रल के बाहर लिख सकते हैं. सो वी कैन राइट 1/4e आउटसाइड द इंटीग्रल, एंड फर्दर इट विल बी e raised to power t dt. Now, for the rest of the terms means for these terms, we have to arrange these terms in this way, in terms of f of x plus f dash of x. So let's see whether we can do this or not. So if I separate the denominator, it will be t upon t square minus 1 upon t square, correct? So further it is 1 upon 4e integration e raised to power t. It will be 1 upon t plus minus 1 upon t square, bracket close, and this is what dt. Okay. Now just compare this expression, this complete expression with this, and you will find that e raised to power t, this is your f of t and this is f dash of t, correct? So this complete integration will be, now 1 upon 4e, it will remain same, and integration of this will be e raised to power t into 1 by t, correct? Check करो एक बार, clear ना शेवी नैना?
Sir, I got, ma'am. It's
Yes,
like
sir.
1 upon 1, t plus 1 is the direct differentiation of minus 1 upon 1 plus t whole square, no? Like in my
Yes,
question.
yes,
So
yes.
we can directly write it as
Yes,
1
in your
upon 1 plus
solution
1.
you have not considered that e raised to power t. Okay.
Yes, sir.
Further put the value of t. So value of t is 1 plus 2x, and here upon 1 plus 2x or 2x plus whatever it is plus c. That's it. This will be your answer. Further, you can also simplify this, like you can subtract the power by applying laws of exponent. So it will be e raised to power 2x divided by 4 under bracket 2x plus 1 plus c. That's it. कुछ doubt नैना पूछ लो, otherwise हम next questions पे move करते हैं.
Sir, here in the book it is written that hint put 2x equals to t, and I have tried solving by that method, but I was unable to solve.
हाँ, उससे भी बन सकता है. 2x को t लेके सॉल्व करते ना तो भी आ जाता सॉल्यूशन. मतलब बस आपको ना ये देखना पड़ेगा कि कैसे हम ये दो फंक्शंस में अरेंज कर सकते. ठीक है. आई थिंक शेवी ने उस अप्रोच से बनाया है. शेवी, यू माइट हैव टेकन
Yes, sir.
2x.
I got my answer now.
Okay, so you can share that solution also with in group. Okay.
Yes, sir.
ठीक है, मैं ये हटा रहा हूं. फिर नेक्स्ट क्वेश्चन देखते हैं. पेज नंबर कौन सा एक बार बताना. ऑफलाइन में आज कोई भी नहीं है तो ऑनलाइन ही चल रही है पूरी क्लास. तो आप लोग कंटिन्यूअसली जो भी डाउट्स है पूछते रहना. ठीक है.
And sir, like in such question where we just have one numerator, like we got t upon 2. So in such cases, we should always take plus and minus of a particular number. Like
Yes,
plus 1 and minus 1, like we have taken.
yes, we can do like that. Like what you have done in that screenshot you have shared, na?
Yes, sir.
Yes, we can do like that, but it is not exact. Actually, it is not anything standard that always we have to apply and we can get the solution like that. Because we have to observe these type of question, how we
Yes,
can.
sir. So earlier I thought that maybe with u into v we can solve, like taking our denominator and numerator, but then it will be complicated.
No. In the first solution, you are trying to solve it by taking e raised to power t as first function and remaining as second function. So it will not
Yes,
be
sir.
that easy to solve by parts. Okay. So I think we can start with next exercise. 7.9 is completed, I think. Let's start with next exercise, that is 7.10. Now this exercise, from this exercise we will start with definite integral. Okay. So till now, whatever questions we are doing are based on indefinite integral. Now from here onwards, it is definite integral. Now let me explain this, what is definite integral, with some example and what are its application also. Let us consider a function y is equals to f of x. Y is a function of x, and y is equal to, let us consider y is equal to 2x plus 1. So this is the function. Okay. Now if you want to find integration y dx from 0 to 2. Now these are the limits. So we are integrating this function for this interval only. What does this means? Let me explain you the actual significance of this definite integral. So here the function y, that is equal to 2x plus 1. So it is a function of line. If we want to plot this line, draw this line, so we need coordinates x and y in that line. So to find coordinate, what we used to do in our class 9th and 10th, we have to put the value of x. Suppose I'm putting x is equal to 0, we will get y is equal to 1. Now put the value of any value of x. Let us consider x is equal to 1. we will get y is equal to 3. So we got 2 points. First point is 0, 1. So this point will be here 0, 1. Next point is 1, 3. So 1, 3, this point might be here. So if we join these 2 points, we'll get the equation of line. So this is the equation of line y is equals to 2x plus 1. Okay. And this is your x-axis, this is your y-axis. Now here we have to calculate the integral of y for the interval 0 to 2 with respect to dx. So here dx means x-axis and the interval is 0 to 2. It means from this point, that is x is equal to 0, till this point, that is, let us consider this point as 2. So you have to find the integral for this interval 0 to 2. It means the area bounded by this curve, this line and x-axis. तो इसका मतलब क्या होता है समझना, जैसे हम लेंथ ऑफ एरिया ऑफ रेक्टेंगल का फॉर्मूला क्या होता है, एरिया ऑफ रेक्टेंगल इज इक्वल्स टू लेंथ इनटू ब्रेड्थ, करेक्ट, ये होता है फॉर्मूला. सो हियर द लेंथ इज दिस in x-axis and breadth is actually its height, but height is variable in this case, so we will consider this variable height as y and width as dx. So this y into dx will give you the area, and area from which interval to which interval, so from 0 to 2. So this is what it will give you, an area, correct. So jo definite integral hai, it will give you the area under the curve and any axis like x-axis or y-axis. Right now we are integrating with respect to x-axis, so it will give you the area bounded by the x-axis and that curve. If we are integrating with respect to y-axis, then we might get the area bounded by the y-axis and that line of that curve, correct. So this is what definite integral, and this is how it is useful. So another chapter is there named as application of integral. In that we will discuss these topic in detail. Okay. So right
Yes,
now,
sir.
how we calculate the definite integral, that topic we have to focus right now. So just put the value of y here in this definite integral. So it is 0 to 2. Put the value of y. So value of y क्या है, 2x plus 1 dx. अब इसके बाद क्या करना है, इंटीग्रेट करना है दोनों टर्म्स को. तो 2x, तो 2 एज इट इज रहेगा, x का इंटीग्रल क्या होगा, x स्क्वायर अपॉन 2 प्लस 1 का इंटीग्रल क्या हो जाएगा, x, और लास्ट में क्या आ जाएगा, प्लस c. ओके, बट यहां पर इंटीग्रेट करने के बाद हम यहाँ लिमिट्स अप्लाई करेंगे जो लिमिट्स गिवन है. तो ये जो पूरे फंक्शन का इंटीग्रल आया, उसमें हम यहाँ पर इसको लिखेंगे लोअर लिमिट जो कि क्या है 0, फिर उसके बाद ये लिखेंगे अपर लिमिट दैट इज इक्वल्स टू 2. तो यह आ जाएगा 0 to 2. अब फर्दर इस पूरे फंक्शन को सिंप्लीफाई करो तो यहां पर ये 2 और 2 वाली टर्म कट जाएंगी और आपके पास क्या बचेगा इस जगह पे, एक्स स्क्वायर प्लस एक्स, और यहाँ लिमिट्स आ गई 0 to 2, लास्ट में प्लस सी एज इट इज है. ठीक है, यहां तक का प्रोसेस क्लियर.
Yes.
अब देखो क्या करना है, अब हम पुट करेंगे फंक्शन में अपर लिमिट. तो ये अब जो पूरा एक्सप्रेशन आपको दिख रहा है ये पूरा फंक्शन है. अब हम पूरे फंक्शन में पुट करेंगे अपर लिमिट. अपर लिमिट मींस इन प्लेस ऑफ x वी विल पुट 2, सो इट इज 2 स्क्वायर प्लस 2 minus lower limit. Lower limit means wherever there is x in this function, we will put the lower value, lower limit value, that is 0 here. Okay, so it is like upper limit minus lower limit, and at last whatever is there, here it is c, so we will write plus c.
So we will always put it in the form of mod.
No,
Again,
actually it is not mod, it represents that the function is integrated. Now it is bounded between these limits. Okay,
yes.
we can also write like a square bracket, we can also represent like square bracket also. Okay, that is also fine. Okay, so further by solving these expression we will get 2 square, that is 4, 4 plus 2 is 6, so 6 minus, for this term it is 0, plus c, and we will get 6 plus c. Sorry, one correction is there. In case of indefinite integral there is no c. In case of indefinite integral, the term c will not be there. The term c is there only in case of indefinite integral. For definite integral it is not there. Okay, so here the area of this region will be 6 square unit. Correct? Clear? Naina, clear?
Means after integrating, we have to substitute the value of x with in the form of upper limit and lower limit.
करेक्ट. जो भी इंटीग्रेट करने के बाद फंक्शन आया उसमें पहले अपर लिमिट पुट कर देना, फिर माइनस उसी फंक्शन में लोअर लिमिट पुट कर देना, और आपको वो टोटल डेफिनेट इंटीग्रल की वैल्यू मिल जाएगी. क्लियर है ना?
Yes, sir.
अभी क्वेश्चन करेंगे और क्लियर हो जाएगा. चलो स्टार्ट करते. एक्सरसाइज 7.10. सो एक्सरसाइज 7.10 क्वेश्चन नंबर 1. Question number 1. So first part of first question is integration 2 to 3 x square dx. तो आपको ये डेफिनेट इंटीग्रल फाइंड आउट करना है. तो सबसे पहले क्या करोगे, एक्स स्क्वायर का इंटीग्रल निकाल लोगे, तो वो क्या होता है एक्स क्यूब अपॉन 3. ठीक है. अब यहां पर ना ये एक्स क्यूब में लिमिट लगा दो 2 से 3. ठीक है. नीचे वाली टर्म 1/3 उसमें x नहीं है इसलिए उसको बाहर हटा दिया, और यहां पर जब लिमिट अप्लाई होगी तो क्या हो जाएगा, अपर लिमिट मतलब 3 स्क्वायर माइनस लोअर लिमिट 3 क्यूब माइनस लोअर लिमिट मतलब ये हो जाएगा 2 क्यूब. फिर 3 क्यूब को सॉल्व करो. 3 क्यूब कितना होता है 27 माइनस 2 क्यूब होता है 8. तो 1/3 एज इट इज. 27 माइनस 8 कितना आ जाएगा 19. सो आंसर विल बी 19/3 स्क्वायर यूनिट. समझ में आया ये पूरा? यस.
Yes, sir.
नैना क्लियर कैसे करना है?
Yes, sir.
तो चलो एक्सरसाइज सॉल्व करना स्टार्ट कर दो. कंटिन्यूअसली पूरे क्वेश्चंस बनाओ, जल्दी जल्दी बन जाएंगे, स्पीड अप भी हो जाएगा और जो डाउट्स है वो भी क्लियर हो जाएंगे. कम से कम 4-5 क्वेश्चंस तो अभी बना लो. सॉल्व करो. मैं 2 मिनट में आया. ठीक है. Yes. Any doubt from any question?
No, sir.
The log of 1/4 can be written as minus of log 4.
Yes, minus log 4. How it can be written like this? Is it clear?
Yes, so because it is 1/4, no? So
Yes, so
we
it
can
will be
take
4 raised to power minus 1, so we can
-1.
take 1. Yes. नैना कौन सा क्वेश्चन सॉल्व कर रहे हो?
Question 2 second.
Okay.
Sir,
Hmm.
I'm getting incorrect answer of question 2 first part.
Question 2 first part. Okay, so here it is integration -4 to -1. It is 1 upon x dx. Okay, so first integration of this 1 upon x is what? It is log x. Okay, but actually it should be log mod x. It should not be log x, because logarithmic function, whenever you are getting a integral as logarithmic function, you always have to write log mod x, but we ignore many times because logarithmic function is defined only for positive values. It is not defined for negative. Okay, so it will be log mod x, and further it is -4 to -1. Now put the upper limit, so it will be log mod of -1 minus lower limit, so it will be log mod of -4. So log mod of -1 is nothing but log 1 minus log mod of -4 is log 4, correct? Now value of log 1 is 0, so you can directly write it as 0 minus log 4. That's it. This will be your answer. Clear? Naina?
Yes, sir.
Hmm.
So how do we integrate root of 5x plus 4?
Which question it is?
It's the question number 2, third part.
Uh, Again, you have to apply substitution. Let me explain that question. We can solve that question by two ways. So you have to understand both the ways of solving that by using substitution. Okay. So ध्यान देना उस question पे. नैना तुम भी. Question number 2 second part. So in question number 2 second part, I is equals to integral, limit is from 0 to 1. It is 1 upon 2x minus 3 dx. So the first way is what we are doing previously, like write 2x minus 3 is equals to t, differentiate this, so you will get 2 is equal to dt by dx, and further you will get dx is equals to dt by 2. Now put the values here and it will be integration. Integration here, in place of this it will be 1 upon t, and in place of dx it will be dt by 2. Now take 1 by 2 outside the integral, so 1 upon t dt. Now integrate this expression, so integration of 1 upon t is what? It is log t and log t. Okay, now put the value of t, so the value of t is log 2x minus 3, and after this apply the limits. Okay, So apply upper limit minus lower limit. You can write mod here. Okay. You can write mod t. So for upper limit, it will be log mod 2 into 1 minus 3 minus log mod 2 into 0 minus 3. आ रहा हूं थोड़ी देर में ना, मेरी क्लास चल रही. Okay. Is this step clear? Further, it will be 1 by 2 log, it is mod 2 minus 3, that is minus 1, minus log, it will be mod minus 3. Okay. Further, it will be 1 by 2. Here it will be log 1, that is equal to 0, and it is minus log 3. So this will be the final answer, minus 1 upon 2 log 3. Further, we can also solve it like this also. If we want to simplify more, so it will be log 3 raised to power minus 1 by 2, and we can write it as log 1 upon 3 raised to power 1 by 2, and further we can also write it as log 1 upon root 3. So this can also be the answer. Okay. Is this step clear? Chevy, Naina?
Yes, sir.
Yes,
This
sir.
one I was able to solve.
Naina, clear na?
Yes, sir.
अच्छा, जो दूसरा मेथड है वो भी समझ लो. Second method, how we can solve by another method. Another method is nothing but it is same, just we change the limits also. So here the t, we have substituted t as 2x minus 3. Further, after integration, we are again putting the value of t. In place of that, we can change the limit. So how we can change the limit? So here t is equals to 2x minus 3. Now what was lower limit? It was x is equal to 0. So when we put x is equal to 0, we will get t is equal to minus 3. So this will be our lower limit. Okay. Further, when we put x is equal to 1, that means for upper limit, x is equal to 1, we will get t is equals to, in place of x, if you put 1, so it is 1 minus 3, sorry, 2 minus 3, that is minus 1. So upper limit will be minus 1. Now put these limits right over here where you have applied the substitution. So after this step, I have not written the limit. Just look at the solution. I have not written the limit here. You can see. From after this step, I have not written the limit anywhere. Just after putting the value of t, I am putting the limit, applying the limit. ओके, सो यहाँ पर क्या कर सकते हैं हम? यहाँ पर लिमिट्स भी चेंज कर सकते हैं. तो यहाँ पर देखो, जब हमने t को रिप्लेस किया, 2x माइनस 3 को रिप्लेस किया t से, तो लिमिट्स क्या चेंज हो रही है वो देखो. अपर लिमिट अब हो जाएगी -1, लोअर लिमिट हो जाएगी अब -3. सो यहाँ पर सीधा -3 to -1 कर सकते हैं. ये -3 to -1 हो जाएगा, और यहीं पर लिमिट अप्लाई कर दो t में. सो ये क्या हो जाएगा? log mod -1 माइनस लॉग मॉड -3. ठीक है. और उसके जब फर्दर सॉल्व करोगे सेम आंसर मिलेगा. ये हो जाएगा log 1 माइनस log 3. ठीक है. और log 1 की वैल्यू तो 0 होती है, तो -1/2 log 3, तो सेम आएगा. तो आप ये भी कर सकते हो कि लिमिट भी वहीं पर चेंज कर दो, और उसके बाद फिर आपको एक्स पुट करने की जरूरत नहीं होगी. ठीक है. समझ में आई ये चीज? ओके.
Yes, sir.
ठीक है. नेक्स्ट क्वेश्चन ट्राई करना है. नेक्स्ट क्वेश्चन में भी लिमिट चेंज करके कर सकते हो. फॉर नेक्स्ट थर्ड पार्ट ऑफ क्वेश्चन 2, जस्ट सब्स्टिट्यूट 5x plus 4 is equal to t, and further rest of the process will remain same. You can also change the limit for that question. मैं 1 मिनट में आया, तब तक ट्राई करो आप लोग. हाँ, तो ये क्वेश्चन हटा रहा हूं मैं, नेक्स्ट क्वेश्चन देख लेते हैं। ये हटा दो ना, नैना, हो गया ना?
Yes, sir. So actually for this third part, I'm getting 2 bracket 5x plus 4, 3 by 2 upon 15.
Okay. Just wait for the next question. It is I is equals to integral 0 to 1 root over 5x plus 4 dx. Okay. So substitution apply कर रहे हैं, तो 5x plus 4. You are substituting 5x plus 4 is equal to t. Okay. Now what you are getting for dx? It is, I think, dt by 5. Now we have to change the limit also. So for lower limit, it is x is equal to 0. So for x is equal to 0, we will get t is equal to 4. For upper limit, it is x is equal to 1, and we will get t is equals to 9. Okay. So this complete integral will be integration. Now it will be from, instead of 0 to 1, it will be from 4 to 9, and it is root t, and in place of
Okay,
dx,
so like if we are solving it in the form of other variables, so we have to like equate the equation in this way.
yes, means
So like we cannot directly write 1 and 0 for root 2, root t.
yes, we cannot write 0 and 1 limits. Na, we have to change the
Yes, sir.
limits, because
Mhm.
if we are changing the variable, then this limit should also be changed. If we are not changing the limit, only changing the variable, then it is wrong. Okay.
Yes, sir. And so then we will be integrating root t also, no?
Yes, after this we have to
Yeah.
integrate root t. So here root t is t raised to power half. We can take 1 by 5 outside dt, and the integration of root t is t raised to power half is t raised to power 3 by 2 upon 3 by 2, and the limit is from 4 to 9. Further, we can do the reciprocal, so it will be 2 upon 15, and it is like t raised to power 3 by 2, limit is from 4 to 9. Okay. Now apply the limits. So when we apply the limits, it will be like 2 upon 15. Upper limit will be 9 raised to power 3 by 2 minus 4 raised to power 3 by 2. Further, it is 2 by 15. So we can write 9 as 3 square whole raised to power 3 by 2 minus 2 square whole raised to power 3 by 2. And further, it will be, यहाँ से ये 2 और 2 cancel out हो जाएगा.
So
So
like if there we write t as 5x plus 4 and then put the value of 9 and 4, so it will be wrong?
if we put the value of t and after that apply that
Yes.
limit, yes, that will be wrong.
Okay.
If you are putting the value of t, then you have to apply the limits of x in terms of x only. Okay.
Yeah, yes, sir.
So answer is 38 upon 15. Yes. अच्छा, नैना, हो गया? ये समझ में आया?
Yes, sir.
Now first part of third question. ये हटा दे रहा हूँ. ये हो गया ना नैना? हटा दो ना?
Sir, please wait.
Okay. कौस्तुभ, डेफिनेट इंटीग्रल पढ़ना है क्या? हाँ, ठीक है ठीक है। मैट्रिसेस डिटरमिनेंट्स इनका हाफ ईयरली चलता रहेगा ना, छुट्टी मारेंगे तब छोड़ देंगे। क्या हाफ ईयरली देगा, डमी वाला है। ठीक है, इंडेफिनिट तक आ रहा है। अच्छा ठीक है, हाँ वो पूरे प्रीवियस ईयर क्वेश्चंस उसको सॉल्व कर लेना। ठीक, अभी बाकी चैप्टर अच्छे से कर ले, रिपीट में करवाऊंगा डिटेल में पूरा, ठीक है। यस, एनी डाउट्स फ्रॉम एनी क्वेश्चंस? थर्ड का,
Just solving.
हाँ नैना, थर्ड का फर्स्ट बना क्या?
Sir, I'm trying to solve.
इंटीग्रेशन
So log, like a to the power, sorry, log and integration of a to the power x, we write it as
इंटीग्रेशन
log
ऑफ,
of
yes, what is
yeah,
integration of a raised to power x? I think it is a
a
raised
to
to
the power x upon log a.
log a.
Yeah.
Yes, it
So
is.
we'll be writing it in this way only, no?
Yes, so it will be 3 raised to power x divided by log 3. Okay, and limit is from 2 to 3. So here 1 upon log 3 is constant, so we can take outside and apply the limit here. So it is 3 raised to power 3 minus 3 raised to power 2. That's it. So 1 upon log 3. Here 3 cube is 27 minus 9. So I think it is 19. So 19 upon log 3 might be that. No, sorry, it is 18, na? 19, 18 over. 27 minus 9. Yes, it is 18. 18 upon log 3.
Sir, always upper limit will be greater than lower limit.
क्या बोले एक बार फिर से बोला नैना?
Always upper limit will be greater than lower limit.
No, it is not necessary. ऐसा जरूरी नहीं है. Sometimes it can be like this also. It can be like this also, 4 to 2. Okay, so this is also possible limits. ऐसा जरूरी नहीं है. जब हम प्रॉपर्टीज देखेंगे ना डेफिनेट इंटीग्रल की, तब वो देख लेंगे कि जब लोअर और अपर लिमिट चेंज होंगी तो क्या डिफरेंसेस होंगे.
Yes, sir.
Okay, for the next question, it is integration 1 upon x square plus minus 1 dx and the limit is from 2 to 3. तो इसके लिए ये वाला फॉर्मूला अप्लाई होगा.
We can write like that 1 by 2 log, then x square minus 1.
No, 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 no. ऐसा बोल रहे हो क्या, log x square minus 1 like this?
No, sir. 1 by 2. 1 by 2 log
1 by 2 log x
x square minus 1.
No, 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 it is wrong. We cannot integrate like this.
Sir, in previous question we did know, like when we don't have the differentiation of denominator, so we multiply and divide.
In
So
previous,
like it will be 2, 1 into 2, and outside we will take 1 by 2.
okay, no problem. If you are trying to do like that, x square minus 1, we are taking 1 by 2 outside like this. If you are trying to do like this, then if you substitute x square minus 1 as t, so the derivative of this part will be 2x, not 2. 2x, that is dt by dx, correct? So this x is there, but you are not having any x in numerator.
Yeah, yes.
It cannot be solved like this. That's why we have separate formula for these type of questions. And the formula is this. Integration, recall this, x square minus a square dx. Yes, I think it is from
Yes,
exercise 7.7.
Yeah, yeah. Yes, sir.
Sir, formulas which we have used in 7.6 like a by x square minus a and something related to that, where we have to use that formulas. We can't use that formulas in these
Sir,
exercises.
x square minus a square formula is not there. Only in the form of root we have.
Okay, let me check. uh, नैना क्या बोल रहे थे इसके पहले? कौन सा फॉर्मूला? फॉर्मूला इन
Sir,
द
which we have done in 7.6.
7.6. Okay, that partial fraction.
Yes, sir.
Yes, yes, partial fraction can also be applied here. We can apply partial fraction also here. यहाँ पर देखो, इसको ऐसे भी सॉल्व कर सकते हैं. इंटीग्रेशन 2 to 3 we can write 1 upon x plus 1 into x minus 1 dx. Correct? So if no formula is there, actually a formula is there for this integral, but I don't know in your book it is given or not, but in core mathematics a formula is there. Okay, so another way to integrate this type of function is this. And further we can apply partial fraction here, so we can write integration 2 to 3 a upon x plus 1 plus b upon x minus 1. इसको partial fraction बोलते हैं ना. तो partial fraction से हम a और b की वैल्यू निकाल के पुट करेंगे, then further we can integrate. Okay,
Sir, we are having that formula which you were talking about.
ये वाले फॉर्मूले, ये
Yes,
फॉर्मूले.
which is equals to 1 by 2a log mod x
हाँ,
minus a up by x plus a plus c.
यस, यस, करेक्ट. ये है ना? हाँ, ये पेज नंबर
And page number
395 में.
395.
हाँ, 395 में, करेक्ट. 1 upon 2a log x minus a upon x plus a plus c. Chevy, you can check this formula. It is given in page
Yeah,
number
yes, I
29.
got it.
So either we can apply this or we have to apply partial fraction. So I think it is better to use this formula because partial fraction will take a lot of time here. Okay, so just apply this formula. Don't apply partial fraction here.
So just in case we forget, so we can use partial fraction.
Yes, definitely, because this formula is derived from partial fraction only. Okay. So integration will be 1 upon 2a. So here a is 1. It will be log x minus a. So it is x minus 1 divided by x plus 1. And the limits are from 2 to 3. Now apply the limit. So it will be 1 upon 2 log. Upper limit will be 3 minus 1 divided by 3 plus 1 minus lower limit will be log 2 minus 1 divided by 2 plus 1 bracket close. So further it will be 1 upon 2 log, this will be 2 by 4 minus log, this term will be 2 minus 1, that is 1 by 3. Okay. Now apply the property of log a minus, okay, further we can solve it like this, log 1 by 2. Log 1 by 2 minus log 1 by 3. So final answer might be log a by b, so it will be, I think, 3 by 2. That's it.
Sir, I guess it will be 1 by 6.
Why 1 by 6?
We have to take the LCM of 2 and 3.
No, it is minus ना, यहाँ पर minus है ना. So it is log 1 by 2 minus log 1 by 3. So it will be log a by b. Property of log से वो होता है ना.
Oh, yes, got it. Yes, sir, I got it.
Okay.
Sir, sir, in question number 4, we have to separately integrate each of the following.
Yes, we can separately integrate and separately apply the limits also. It takes lots of calculation, but it is easy. Directly, the integration of that part will be x raised to power 4 minus 5 by 3. It will be x cubed plus 3x square plus 9x. So it will be the integral. Further, apply separate in limits. That will be easy. Or you can apply combined limit also like this. If you are applying separate limits, so it will be like this. If you are applying combined limit, then it will be like
Sir, why we
हाँ
have taken 9x?
9 का इंटीग्रेशन 9x होगा ना नैना.
x होता है क्या?
देखो ऐसा इंटीग्रेशन 9x 9 dx है तो 9 आउटसाइड हो जाएगा तो 1 dx बचेगा तो 1 का इंटीग्रेशन x होता है तो इसलिए तो 9x लिया ना.
Yes, sir.
Yes, which questions you are solving?
This question only. Sir, altogether, can we take integration first or like that will be lengthy?
For the first part of question 4,
Yes, sir, this one only.
yes, we can do all. We can take all together also. No problem with that.
Sir, so the like shortest method will be this one or taking integral
Actually,
altogether?
both the methods are equally lengthy, but in the first case, we might have some calculation error. So that's why I suggest this because some small calculation will be there here.
So like here without integration we have first put the values. So we will not be doing integration here.
In which?
So this question only.
No, I have directly integrated that part. I have not written the question. Just look at the question from your book. The first term is 4x.
Yeah. Yes, sir. Yes, sir.
नैना कौन सा क्वेश्चन सॉल्व कर रहे हो?
Second part of fourth.
अच्छा. हेलो. Chevy and Naina, which questions you are solving?
Sir, I am solving question number 4, second part.
Okay.
Sir,
हाँ बोलो नैना.
I got stuck.
कौन सा क्वेश्चन?
Same fourth second part.
अच्छा. Integration 0 to 8, it is root 8x minus x square divided by 8 dx. Okay. So first हम इसको सेपरेट कर देते हैं. रूट 8x dx वाली टर्म अलग माइनस इंटीग्रेशन x स्क्वायर अपॉन 8 dx वाले टर्म अलग, ठीक है। सो यहाँ पर इसको फर्दर ऐसे भी सेपरेट कर सकते हैं, √8 √x dx माइनस 1/8 इंटीग्रेशन x स्क्वायर dx. √8 can be taken outside the integral, so it will be like this, dx minus 1/8 integration x square dx. It will be like this. Okay. Further integrate the two parts. First part is this, and second part is this. Second part is this, and apply the limit separately. So here, the integration of this part will be x raised to power 3/2, or we can also write like x root x divided by 3/2. Okay, limit is from 0 to 8. And for this part, it is like 1/8 x cube upon 3. And limit is again from 0 to 8. Okay, now apply the limits. So when you apply the limits, first it will be 2√8/3, this term. When you apply the limit, it will be 8 raised to power 3/2 minus 0 raised to power 3/2. That is nothing but 0. Minus 1/8, 3 is 24. Again, it is 8 cube minus 0 cube. Okay. So further, here we can write √8 as 2√2. So it will be 4√2 divided by 3. And here this term, 8 raised to power, this is 3/2, na? So what we can write? We can simplify it like, we can write it like 2√2 whole raised to power 3. Or also 2 cube. We can write 2 cube raised to power 3/2. So it will be like 9/2 minus 2 to 8. It's a 64. 64 into 8. 64 into 8 divided by 24. So 2 12s are 2 4s are 2 6s are 2 2s are. So it will be 3, 64 by 3. So this term will be 4√2 divided by 3 into 2 raised to power 9/2 minus 64/3. और इसको देखो क्या लिख सकते हैं, 2 into 2 raised to power 1/2 into 2 raised to power 9/2 upon 3 minus 64/3. Further, the power of 2 will be added and it will be 4 into 2 raised to power 10/2 upon 3 minus 64/3. Further, it will be 4 into 2 raised to power 5 divided by 3 minus 64/3. 2 raised to power of 5 is 2 to the 4, 2 the 8, 2 the 16, 2 the 32. So it is 32. 4 into 32 divided by 3 minus 64. So 4 to the, it will be, I think, 128. Yes, it is 128/3 minus 64/3. So final answer will be 64/3. Check कर लो एक बार. Clear है क्या?
Yes.
हाँ. कैलकुलेशन में प्रॉब्लम जा रही होगी, आई थिंक, बाकी तो कोई इशू नहीं है.
Yes, sir.
अभी इसके बाद वाले क्वेश्चंस में इंटीग्रल में भी इशू जाएगा. मैं हिंट करूंगा सारे क्वेश्चंस को, जल्दी जल्दी ट्राई करोगे घर में.
Sir,
हाँ,
sir, I was saying that अगर हो सके तो संडे की आप प्रोबेबिलिटी की क्लास ले सकते हो क्या?
संडे प्रोबेबिलिटी ठीक है, ले लूंगा इसको.
क्योंकि ट्यूसडे को पेपर है.
ट्यूसडे को है. ओके, ठीक है, ले लूंगा इसको, होल्ड करके कर लूंगा प्रोबेबिलिटी. ठीक है.
प्रोबेबिलिटी में सिर्फ 3 ही एक्सरसाइज आ रही, बाइनोमियल डिस्ट्रीब्यूशन तक.
कौन सी 3 एक्सरसाइज आ रही है?
स्टार्टिंग की 3 बाइनोमियल डिस्ट्रीब्यूशन
बताना.
तक.
अच्छा, बाइनोमियल डिस्ट्रीब्यूशन तक आ रहा है. ठीक है, मैं वो ले लूंगा फिर. फर्स्ट 3 एक्सरसाइज शॉर्ट में एक ब्रीफ कर दूंगा उसको, और कुछ इंपॉर्टेंट क्वेश्चंस बता दूंगा. ठीक है.
Sir, please take my class for chapter 1. So because like in all the questions we have to apply different approach. Like although the topic is easy, but answer is not coming every time. Like we're solving it.
Actually, first part consists of different sections. Actually,
Yes, sir.
no each section is related to each other. Like first section is based on modulo operation, second
Yeah.
section is I think based on mixing. Okay,
Yes, sir. Then we have boards and streams, pipes and cistern.
so specifically which category you want, because to complete all the questions from this it will take time. It cannot be completed like in 2-3 hours or 1 hour. Okay,
Sir,
so
I will let you know. I'll revise my chapter one soon. So from that, I'll let you know that majorly from which topic I want to understand.
yes, because if I explain in short, then it will not be helpful to solve the questions, because each questions are of different category and each for each type. Like for example, for modulo operation only, we have to apply different approach for different questions. So yes, it takes time.
And I was thinking that shall I take off on Saturday?
अच्छा, सैटरडे को ऑफ लेना है बोल रहे हो नैना, क्यों?
Sir, there are so many chapters coming in our exam.
अच्छा ठीक है, सो देख लेते हैं उसको, सैटरडे ऑफ कर लेना, संडे को मैं वो प्रोबेबिलिटी कर लूंगा, ठीक है, बट रिकॉर्डिंग बाद में उसको कवर अप कर लेना. ओके
Yes, sir.
So when is everybody's exam there for maths?
एक्चुअली दे हैव डिफरेंट डेट्स.
Like in September only, no? The ending.
Yes, on September only. I think for other twos, the exam is already started for different subjects.
Yes, sir. Even ours started today. I had English exam first. On 21st, it will be maths.
21st April, you have maths. And Naina, your maths exam is on which date?
20th September.
20th. Okay. Okay, so I will try to cover some topics. So we can halt this topic also, and I can take that probability on Sunday. And for any doubts from any section of that first chapter, let me know, Chevy. I will cover that topic on
Sir,
Saturday.
and our teacher told that majorly 5 marks question will come from the last exercise only of this integral chapter.
Okay, and that exercise is what? Which one?
Application based and like this definite integral hard questions.
Okay, based on properties of definite integrals from exercise 7.11 or 12.
So like 7.11, 12, 13,
Okay,
14 also.
okay, no problem. I will continue with this integral part.
So
And
I think 13 and 14 are related to that only, no differentiation when we just have to do the reverse thing.
yes,
Fine.
okay. Application of integral is coming in your exam.
Yes, sir, it is.
Okay. So we will continue with this topic also, and on Sunday I will take probability, class of probability. Probability is there in your half yearly syllabus? Not
No,
there.
sir.
Okay. So I will take probability on Sunday, and rest of the for rest of the classes it will be, we will continue with the integrals. How much or whatever topic we have completed, just make sure you are able to solve those questions. Maybe we will complete till that point whatever application of integral is there. Okay.
Yes, sir.
Okay. So any doubts or any specific question from this exercise you want me to explain?
So we will try solving it first. Then
Yes.
we ask.
Okay, so try to solve the rest of the questions, or I'm just stating the hint. For first part of fifth question, rationalize the denominator. That will be helpful. For the second part, separate the denominator like 1 upon 1 plus x minus x upon 1 plus x. For the third part, you can apply partial fraction. So for 3 parts of question 5, different approaches will be used. Now for the sixth part, what you can do is you can apply partial fraction in sixth part also. Sixth first part, apply partial fraction. For sixth second part, again partial fraction can be useful for this. For the seventh question, first part of seventh question, you can apply by parts, integration by parts, because product of two function is there, first function, second function. Okay. In the second part of seventh question, apply that formula what we have seen in starting of today's class. E raised to power x under bracket f of x plus f dash of x. Correct. So integral of second part of question 7 will be directly e raised to power x upon x. Now you just have to apply the limits. So you can solve all these questions with this hint. And question 8, 9, you can try by looking some examples, see if it is available, or I will explain in next class. Okay?
Yes, sir.
ठीक है. So आज की class end करते हैं. Thank you.
Thank you, sir.
Thank you, sir.
Welcome.